All right, so welcome. Hope you guys are having a good start to the semester. Maybe this is your first class this semester. So this is Introductory Algebra, Math 095. We'll talk a lot of administrative stuff in a little bit, but the first thing I like to do in a math class is some math. So we're going to jump in on page 8 of the big blue packet. So let's see if everybody can start there. It looks like this up here at the top. Everybody has one of these? Yes? Okay. All right, so I talk too much in my classes anyway, so I like to ask students to read aloud. I hope that's okay with you. Could you read the objective for us? Thank you so much. Can you read number 1?
Yes. In 1980, 800,000 Chinese in the U.S. Population increased by 104.1%. Population increased.
Oh, go ahead.
So let's begin by
all right, so there's some data. We're going to organize it in the chart. The first year that we're interested in, the first year we have information in is 1980. So how about we throw 1980 there in that first spot? And how about the right below that, what number would be relevant? 1990, so we'll throw that one in there. That's what we're interested in. And then reading this very carefully, it says Chinese population in the US in thousands of people. There's only one number that goes in there. What number should that be? So I heard the two answers that I was expecting. One person said 806 and one person said 806,000. Which one is the right answer? Again, reading that label very carefully.
806.
Several people are saying 806. What do you say in the back? 806,000. What do we think? We need people to make their case. Both answers are reasonable. Unfortunately, only one is right. All right, go ahead. Yes.
Because it says what's the population, right? So we put 806 the bottom of 806 high. So 104.1, but if you pick up the patient, so we can go out to 1,000.
Okay, we definitely have to deal with the decimal point and that percentage. And I think you're exactly on the ball in terms of how we're going to figure out that bottom number. That's the tougher problem. I still got to figure out what's going on in that first row, which is the easier one. Is it 806 or is it 806,000? Yes.
806
Excellent. Do we buy that? That phrase right there tells you you don't get to put the number that's in the paragraph. You have to translate it because the table doesn't exactly correspond. This is straight 806, not 806,000. Questions on that? Okay. Okay, so the harder part is to figure out what goes in this bottom row. I'm going to change the question and make it a little bit easier. Forget this increased by 104.1% for just a moment. Suppose that I change that. Don't change it. But suppose I change it to it increased by 3,000 people. If you start with 806,000 people and then we increase by 3,000 people, how many do we have at the end? 809. So it's pretty clear that what we need to do in this row is take the 806 and then add whatever the increase in population is. Yes? That's what we need to put in there. Okay, so now we get to this issue of how do we handle the 104.1%. So what's your name? Geneva. Geneva talked about taking the 104.1% and I think you said multiply. What do we think? We're trying to find 104.1% of the 806,000. 104.1% of 806. The 1,000 is implied. How do we do that? We buy multiplication. That's what Geneva said. Right? To find a certain percentage of a number, we multiply. So then I'll translate this. 104.1% of becomes multiplication. There are two really common symbols for multiplication. I'm going to encourage you to use one over the other, but what are the two different ways we can write the multiplication symbol? We can put a dot. That's the way I'd really like us to use. What's the other way? Is an X. 104.1% times 806. Why do I encourage the dot over the X? It's an algebra class, and we're going to see x every single day in this class, and it's going to mean a variable. So I'd encourage you not to use this one, so I'll put, it's fine, but it's dangerous. Okay, so one other thing that Geneva mentioned was dealing with this percentage. We don't get to just multiply 104.1 times 806. We have to translate the 104.1%. So let's do that. What is 104.1% if you don't like to say percent at the end of it? Remember how to go from a percent to like a plain number to a decimal. We do. We move the dot somewhere. Which way do we move that dot? I hear. Well, let's actually think about this word percent. In the back of this word, welcome to Intro Algebra, come on in. In the back of this word, you see CENT. What number does that represent? 100, right? Century, centipede, lots of things with CENT. A cent is a hundredth of a dollar. So this has something to do with 100. Per means out of, and so percent means take your number and take it out of 100. That's what 104.1% is. Yes. Thank you. There you go. No problem. Okay. And does this help? Dividing a number by 100. It moves the decimal point. Have we made 104.1 bigger or smaller by dividing it by 100? Definitely making it smaller. You're cutting it into 100 little pieces. How many times do we move that decimal point to the left to make this number smaller? It's twice. It's actually the same as the number of zeros that we have down here. So we're going to move that decimal point 2 places to the left. And let's do that here. So this becomes 1, we move it 2 places, 0.041 times the 806. That's the magic number that we're after. Oh, because I forgot it. Thank you. Okay. I'm not going to ask you to do a lot of crazy multiplication without a calculator in this class. Most of our quizzes and tests will be non-calculator, but I'm not going to give you numbers as bad as this. So if you have a calculator handy, maybe even on your cell phone, this is one of the few times I want you to use your cell phone. Let's go ahead and just find this. I'll do it up here, but we want to make sure that we know how to use whatever calculator we have. If you don't have a calculator, I can lend you one on quizzes and tests, but if you have one, you should be bringing it to a few of the classes. We'll tell you which ones. Yeah, 1.041 times 806, 839 and change. Come on in. How about this table right up here? There's only 2. Okay. So 839. We'll put that here. So this is about 839. Right, we've seen the squiggles for approximately equal to. Okay, 839, is that the answer? Is that the Chinese population in 1990? It is in thousands, so it's a. Yeah, that's it. This is the increase. This is how many people the Chinese population increased by. So we're going to add the 839 to the 806 that we started with. So total population is equal to the old population plus the new population. The old population was 806,000 plus the new population, 839,000. Add them up, 1645. And we'll fill that in into the blank in our table up here. Okay, this is not the easiest problem that we're going to do this semester. but I think it's an okay problem to start with. It kind of wakes up some of these like math neurons that have been asleep for maybe 4 or 5 weeks for you guys, and got us to think about increases, got us to think about percentages. Oftentimes we'll end up putting a lot of complicated information in a table, so it brings together a bunch of different ideas that we'll use this semester. All right, if you go to the next page, you will see our first bar graph. So what I'd like you guys to do is introduce yourself to the people sitting around you, and then see how much of this page you guys can do. Go ahead. Table of contents. All right, so looking at this big blue packet, I promise you I won't give you a big blue packet every class. This packet represents how we will spend our time together in class. It's called the class packet. It's class packet number 1. There are 3 of them for the semester. So that's about 1/3 of the class packet notes that I'm going to hand you, all right? And if you go to the inside of the front cover, you will see a table of contents. And so if you're ever looking for something, it's really, really well organized. And I have my colleague Sandy, she teaches this class as well, to thank for how nice this thing looks. So if you're looking for something, know that there is a table of contents here. And if you go to the next page, you will see that it goes all the way up until there's something crossed off. And the thing that's crossed off starts at lesson 12, which is right after our first exam. So essentially, this packet covers the material up to the first exam, and then I'll give you another packet that will cover everything up to the second exam, and then one final packet at the end. Question here? Oh, is it not crossed off?
No, they're not.
Oh, what's on the next page? Does it just jump to page 8? 6, 7, 8, yeah. Okay, that's fine. You can cross it off if you want to. I just don't want you to be confused. There's stuff referenced here that you don't have yet. It starts on page 100, which I will give you in like a month. Okay, so let's take a look at the next page, which is page 6. And it says up here, this section is simply meant to highlight key things. You're going to see the first day handouts. That's the very colorful packet of thin things that you should have as well for more details. Now, I recognize that administrative stuff and talking about the syllabus is really not interesting for students. I recognize that. So we're just going to try to fly through this. It's going to be a lot of information coming at you in a short period of time. And not all of it is going to make sense today. It'll make more sense over the first few classes as we kind of find our rhythm and you understand how the class works. So we've already formed your groups. If for some reason a group is not working, if you have issues with your group, please talk to your group and or talk to me. There's a reason the math department has not selected individual desks to be laid out in rows and columns. We chose these tables so that we could form groups and you guys could work with your neighbors. And if a group isn't working, I want to help. All right, so let me know and or talk to your group. Okay, there is an attendance folder. It is yellow. Right now what you're going to do is just write your name at the top of one of the calendars. You see the word name up there. Doesn't matter which one you write your name on. So just write your name up there, pass it around, and every day you come in, you'll just mark the time that you got here. We started at 9:30. Most of you were here before then. So just write down the time, and this will be our attendance folder. Okay, moving on down. I see there's something that I forgot to do, and that's to put these guys out on the tables. These are what we call flags. And as you guys are working with your neighbors on math throughout the semester, these will be on your table. And if you have a question for me, you just raise a flag, and that'll be my cue that you need some help. So feel free to raise that flag if you ever get stuck. Okay, so now let's see if we can blitz through some of the documents in that very colorful packet. Is there a question over there? Question? Okay, they're keeping you on task over there. All right, documents you receive, you can feel free to write your name on the big packets if you want, just in case you lose it in your textbook. A lot of this information is also available on Moodle, so I encourage you to sign in, maybe explore that page a little bit. Okay, so the first thing in the packet is the syllabus. Sandy's was yellow, but I'm not as organized. Mine is white. So the syllabus is there. There's a lot of information about this course in the syllabus, including how you get your grade at the end of the semester. So read through that and ask me any questions that you have later on this week, okay? All right, the next document is the blue schedule. Now I want to point out that the blue schedule looks kind of strange with holes on both sides. Now on the front of the blue schedule, if you look at the top, it'll say Tuesday, Thursday in the middle. You guys see that? On the back it says MWF for Monday, Wednesday, Friday. You can completely cross off the back if you want to make sure you're only looking at the right side. We are the Tuesday, Thursday class, so make sure you're looking at that one. And if you look at that schedule, you will see lots of good information. So for example, we can write on this, maybe no. For example, up here in this first row, Tuesday the 28th, that's today. In class, we're going to cover sections 1.1 to 1.3. And then Thursday, the homework due is homework 1.1 and 1.2, as well as something called assignment 1, which is a paper. Yikes. So we'll talk about that in a moment. But is it clear how to figure out what's going on with the calendar and the homework? Today we're covering this. Next time the homework due is 1.1 and 1.2. Okay, so how do we know exactly what we're supposed to do for homework 1.1 and 1.2? That's where the next document comes in. It's green. And the green thing is the homework assignments for the whole semester. It is this one right here. So the first assignment is kind of unusual. Come on. First assignment is a little bit unusual. Here it's assignment 1. The typed paper. So I'm not going to talk about the details, but it is all written here. In essence, you're going to head over to the Math Studio, which is this wonderful room right on the other side of, well, it's not quite the other side of that wall, but 50 feet that way. You find this huge room with glass walls. Oftentimes there's a math faculty member working there helping math students on their homework and studying for quizzes and tests and all that. It's a great resource. So what you're going to do between now and Thursday is spend like 15 minutes over there and just get a sense of what that room is about. And just tell me what your reflections are on that room. You're also going to read some letters from students who have already completed Math 095. These are letters that they wrote at the end of the semester, letters to you about how to succeed here as a starting 095 student, all right? But all the details are there. If you go to the next page, you will find up here something called section 1.1 and something called section 1.2. And I will remind you on the blue schedule that the homework due next time is 1.1 and 1.2. So the specific assignment that corresponds to 1.1 and 1.2 is right there in the homework. Section 1.1, it's in the textbook. Section 1.2, it's in the textbook. Okay? You understand how to use the two things together, blue and green? Okay. Next thing after the green, what's after the green? Oh, the memo. White memo. All right, so we are back here. Okay, so we're up to this memo. So there is, I'm just going to draw a little schematic here. Some of you may have come out of Math 090, which is our introductory math class, and it focuses on arithmetic, percentages, decimals, all that kind of stuff. And from there, you are welcome to go to Math 095, which is where you are right now. But I wanted to let you know there's an optional class in between meant for students who either have never seen algebra before or who haven't seen algebra in many, many years. This class that you are in moves at a pretty brisk pace once we get going, and it assumes that you have some experience, some recent experience with algebra. And if you don't, we have this little off on the side kind of let's go things a little bit slower, Math 094. And so if you are feeling overwhelmed, and it doesn't have to be today or tomorrow, it could be really any time in the first month and change, but if you're just feeling like we're moving too quick and it's been too long for you, I want you to know there's this option of switching into another class that might help you kind of get more up to speed so that you're feeling comfortable in this class next semester, all right? That memo gives some details about that option. Okay, that's that. Next thing, the pink even text answers. All right. In your textbook, anybody have the textbook? Just going to grab this right here. So here is your textbook. Specifics on this are in the syllabus, but at the end you will find answers to the odd numbered questions. Most of the homework I assign will be odd numbered questions, so you can check your answers, and in fact that's part of your homework, is to check your answers and let me know whether you got them right or wrong. But occasionally I'll assign something that's even and the answers aren't in the book. I want you to have the answers. So that's what this pink thing is, okay? There we go. All right, and I think that's that. And then finally, this Moodle resources page. I mentioned there's a lot of stuff on Moodle. This kind of gives you the highlights of what's available on Moodle. A lot of documents for extra practice. And on the back, some other documents that are just generally about succeeding in a class, not even necessarily a math class. Okay, so again, I know administrative stuff is not the most exciting thing in the world, and I said most of this will kind of start to make more sense as we get into our groove this semester. Any questions at this stage on any of that? Okay. Yes. Yeah. Does anybody remember how to log into Moodle? There's some default username and password that I.
So just like when you yeah. Oh, okay.
Same as my GCC? Yeah. So log in and you'll see a list of the courses that you are taking now, including Math 095. Click there and you'll see a lot of stuff. I might pull it up one day just to give you a sense of what it looks like. Any other questions? Okay, so last administrative stuff before we jump back into the math. A typed paper is due next class. There are details. Homework from your textbook is due next class. There are some details. You need a textbook in order to do the homework due next class. But I know that not all of you have your textbook yet. It's okay. I have a handout, which is essentially a photocopy of the homework for the first about 4 sections of this course. So if you do not yet have a textbook, see me right after class. I will give you this handout. It will help you and allow you to do the homework for the first 4 classes, first 2 weeks, say, while you're waiting on that book to come in, okay? I want everybody to be able to do this homework, even if you don't have the book in hand just yet. So see me right after class. I'll loan you the handout. Okay, there is some stuff on buying older editions of the books, and that could save you a lot of money. So read it before you place your order if you haven't got this book yet. Okay, so lots and lots of that. All right, so let's move on to jumping ahead to page 10. Okay, and yes, at the top of page 10. Yeah, next page. We'll get you to read for us right up there, please.
All right. Did we discuss?
Yes.
We discussed the set of axes and drawing graph. This data on the cost of renting a car.
Okay, so there's some information in a table. Let's take a few moments to process what's going on here. We're going to rent a car. We have a certain number of miles that we might drive, 0, 200, 300, 400 miles. And then there's the cost of renting a car. And you guys probably already have some like insider information. The more miles you drive, probably the more the rental is going to cost you. So it kind of makes sense looking at the numbers here. I can see that the cost is going up as we drive more and more miles. Fair enough. This is in dollars here, this bottom row. So what we're going to do is we're going to plot some points. You guys remember like X's and Y's and plotting points on graphs? So for example, the first point, I'll just write this one here as 0, 5, top number, and then bottom number. Okay, so how do I plot that point? Like, what do I do? Yeah. Okay, so 0 is the X and 5 is the Y. That's normally the order, right? X first and then Y. Okay. Okay, so this is what you're saying is the X. All right, let's pause. Does that match with your memories? Is it swapped? What do you think? I mean, it's either that or it's swapped. Which way is it? Geneva's switching to Brandon's idea. What do we think? That's pretty good. You're using the numbers that I put on the graph. Yeah, this is correct. X is almost always on the horizontal and Y is on the vertical. Super. So then if I actually want to figure out where the 0.05 is, or what if we just do a different one actually, because the 0 is a little bit special. Let's do 200, 10. How do I figure out where that point lives on this graph paper? Let's hear from someone we haven't heard from yet today. Yes? Mm-hmm. Mm-hmm. Okay. Okay, so we're finding where the 200 is here, and where the 10 is here, and where they meet. Do people buy? This is the point 200, comma 10. Is that fair? Seems good to me. I generally don't think of it as two lines meeting each other, but that's a perfectly valid way of thinking about it. For me, if I'm going to plot any point, I always start someplace, and then I start moving around to get to where I want. Where do you start if you're trying to plot a point? Okay, so if we find the 200, like right here, and then the y tells us to move up 10, yeah? Is there something that would move us from like some starting point to get to 200? Like instead of zipping to 200, is there like a natural place to start? Yeah, is it 0? And in fact, this point right here has a name. What is it? Starts with the letter O. It's the origin. You guys have heard that word before, haven't you? That's the origin. And the word origin means starting point. So that's a reasonable name for that thing. So what that means is you move 200 to the right in the positive x direction, and then you move 10 up. And we land at the point 200, comma 10. Super. Okay, go ahead and plot the other 3 points on this graph paper right here. Here, I got to catch up to you guys. So 0.5 is here, and then 320 is there, and then 440 is here. And then sure, that looks like a straight line, so we'll connect the dots and get a straight line. Is that right? Does this accurately capture the data in the table? One vote for no. Okay, an arrow at the end, that's a good point. I assume we'll go continue the trend. Great. Yeah. Other thoughts? Okay. Yeah, so maybe, right, we could label the points just like 210. Good. Yes? You guys see that problem on the horizontal line? Right, those points, those lines, they're equally spaced in the picture, but they shouldn't be in reality because we skipped over 100. Any other problems, just like that one? Yeah. Right, 5, 10, 20, 40, those should, right, they should not be equally spaced, but it looks like they are. So this graph is really deceptive. Okay, so let's make a better graph. All right, so in the back, what's your name? Of course it is, Megan. So Megan said 100, 200, 300, 400. That seems quite reasonable. So we're going to put equally spaced hash marks, 100, 200, 300, and 400. Okay, that's great. And then I heard the word label before. I still think that we need to put something like this down at the bottom just so that people reading the graph will know what it represents. So number of miles is down there. And then vertically, okay, we could go by 5s. And in fact, that's what I heard. What's your name? Heather. Heather had suggested going by 5s, and we could. But to get up to 40, going by 5s would be more hash marks than maybe by 10s is good. There's no like rule of thumb here, but try not to draw too many. So 10, 20, 30, and 40 at the top. Equally spaced, well, kind of. Okay, so that's good. So now with our new legitimate axes, we can plot these points again. We might have to estimate a little bit, so 0, 5, I guess is right there like halfway. And then go ahead and plot the other 3 points and then try to connect the dots in some reasonable way. Okay, so we've got our 4 points plotted here. Does it still look like they're on a straight line?
No.
So we can see We were really deceived by that first graph because the graph paper just lied to us. So let's draw the more accurate graph. So some kind of a curve thing that hits all the lines. Okay. All right. Any questions on graphing stuff? Hopefully that was a little bit of a review. All right. Next thing we're going to do is a timed arithmetic thing. It's not a test. It's not graded, except by you guys. So it's on the next page, but don't actually start it just yet because I want to time everybody. But before we look at it, so don't look at it. Don't look at it. Don't look. Yeah, don't look at it. Yeah. So this is a non-calculator thing, and most of the stuff we do this semester will be non-calculator. Most of the stuff that we're going to do this semester is going to be in groups. So you guys are going to be working with each other quite a bit. This is one of the few times when I'm going to ask you to do something individually because I want to know, or I want you to know exactly how you are right now at this moment with arithmetic. If you have trouble with arithmetic, then we got to either get you to get up to snuff really quickly in this semester, or maybe ask you to think about stepping back to this other course. Now, this is not a make or break moment, these next 2 minutes for you, but this is just like a real life snapshot. How are you right now? If you cannot do the arithmetic, then no matter how good you are at algebra, you're not going to get through because algebra relies so heavily on arithmetic, okay? All right, so don't start. I'll let you know when to start, but on the next page, there are a total of 40 problems. We're going to give you 2 minutes, no calculators. Do your own work for this one. 2 minutes to do as many as you can. I'd like you to try to get through all 40, but be accurate over being quick, right? Don't finish in 5 seconds and get them all wrong. Okay, so 2 minutes. We ready? Set. Go. Here's what we're going to do. We're going to check your own work right now. You're welcome to look up here, but it might be easier. I'm just going to read these things out loud, and then you can check. So just mark whichever ones you got wrong. Okay, I'm going to go the first row, going straight across. First row, 17, 11, -1, -8. Next row, 0, 90, 3, 8. Next row, 30, 56, 2, 10. 28, 0, 0, 2. 21, 72, 8, 10. 40, 38, 13, 5. 56, 3, 9, 7. 80, 6, 4, 0. 46, 11, 15, 2. 70, 40, 2, 2. Okay, so count up how many you got wrong. Hopefully you got 3 or fewer wrong. The goal on this is about 37 out of 40 or better. Again, if you got less than that, you don't have to tell your neighbors, you don't have to tell me, you don't have to tell anybody, but you should know that you got a little bit of work to do in terms of catching up on your arithmetic skills. Again, you're not going to succeed in an algebra class without a good foundation in arithmetic. Okay, so let's come back to blue. All right, so we just finished this. So suppose that you didn't do so well on this arithmetic thing. What can you do? Well, certainly you can talk to me. But I also want to point out that if you go onto our Moodle site, and this is written right here, right below the quiz, and you go into this folder called Moodle Practice, you're going to see a lot of PDFs. And there are a couple that I want to highlight that you might take a look at for practice on arithmetic. There's something about small positive numbers, something else about multiplying and dividing by powers of 10. And there's lots of other practice in that folder too. So if you didn't do so hot on this thing, check this out. Come talk to me. I'll give you more practice. We want to make sure that you are okay with the arithmetic so that you can have a chance at being good at the algebra. All right, on the next page, there's something there called practice. Now, you're not going to do this problem right now, but generally, the way the class works is I will start off by doing a pretty quick demonstration, something like 5 to 10 minutes. Then there will be classwork, which you will do with your neighbors. That will be the bulk of how we spend our time. And then there will be a quick check, like we just did with the arithmetic, which you do individually. Usually the quick check will check how you were on the previous day's material, just to see how you're doing on that material. And then there will be practice for those speed demons who get through all of that stuff during the time we have allotted and have some time left over to do more practice. Also, the practice is here for people that even if you don't finish in class, but you just want more stuff to practice, it's here. And then occasionally, you'll have some text here which will explain some things. So here's steps for drawing a line graph. We're not going to look at it now, but you should know that there are a lot of good resources in this blue packet. Here's some stuff on prerequisite material. There's a real pretty multiplication table there, some nice techniques, some tricks for multiplying by 9, and some other odd things about the multiplication table. We're not going to look at it, but you should know there's a lot of good stuff in this packet. There's also a program that you have access to that might help you practice arithmetic. Details are there. Okay, we move on to lesson 2. Next page, 14. Okay, so here's what's going to happen at the start of next class. I'm going to get here early, and hopefully many of you, just like today, will get here early. I will check as much homework as I can before class starts, and then we'll start class here in the blue packet. And if I didn't get a chance to check your homework before class, I'll ask you to stick around for just a couple of minutes after class. Sometimes I can try to check homework during class, but my priority during class is to work with you guys on this packet, not to be checking homework. So try to get here a little bit early if possible. And there's more administrative stuff. I don't want to, there's already been too much of this today. So there's a lot of information here for you to check out, lots of resources in many different places. But let's just go ahead and move on to the next page where we'll start doing some more math. Okay, and can we move back here? Could you read the objective for us?
Yep.
Thank you. And we're moving around that same table. Go ahead. Okay, let's pause right there. We are defining this phrase, an equation for something in terms of something. That is really the heart of this particular lesson, and it's an easy concept once you have it, but it's vocabulary that we need to be ready with. We're going to use it. So we've just heard that the equation 7 minus 9t equals p is an equation for p in terms of t. Let's keep going around that table. Can we hear the next one?
The equation P equals 4.
Okay, and let's move on. Geneva, we say? Okay, so that's the heart of this vocabulary here. An equation for something, if the something is by itself. What letter was by itself in the first equation? What letter was by itself in the first equation? It's P. What letter is by itself in the second equation? Still P. So in both cases, we have an equation for P in terms of the other letter, whatever the other letter happens to be. So I don't have any like really nifty mnemonic device here to help you figure out which one is which, but you just got to know if you see an equation for blank, that's the letter that's by itself in terms of the equal sign. Right? And the other letter can be buried inside of numbers and things like that. So let's try number 1 here. Let's move to this back table. Can you read number 1, please? Okay, an equation 4. Whatever comes after this word 4 is the letter that's by itself. What is it? G. The other blank is the other letter in terms of F. Easy enough. Let's go around that same table to the back here. All right, what goes first here? W, the letter that's by itself in terms of A. Notice that on the one hand, the answer that we put first was G, which was the left-hand side, yes? The first answer we put in the other equation was W, which was the right-hand side. Knowing which is on which side gives you no information. It's really not about where the thing is, it's about who's by itself. The letter that's by itself is the equation for blank. Okay, moving on to C in the back. Okay, this is the best kind of math question. There are infinitely many right answers. Write down a correct answer that is different from something anybody else in this room is going to write down. Who wants to share? Someone we haven't heard from. Yes. Z equals 4 plus 2b. Is this correct? Z by itself, an equation for Z. Perfect. Somebody else we haven't heard from yet today? Which is most of us. Yes? 4b minus 10. Is that okay? Good. Can somebody give me an equation where the Z is on the other side? Yes. 3 plus 7b equals Z. It's okay? So hopefully you've written down a different equation from all of those, but the important characteristics are that the Z is by itself and the B is buried with some numbers around it. Any questions about the vocabulary? All right, and I'll grant you it's not the most exciting vocabulary, but it's going to be important for us, so we got to get it straight. Okay, let's take a look at this next problem. It says consider the table, and then there's a bunch of numbers with a couple of blank spaces. So part A says look for a pattern between the vertical pairs of numbers and fill in the blanks in the table. So that's the first thing I want you to do. Try it with your neighbors right now. Find a pattern and fill in those two blanks. All right, so a bunch of folks just kind of had the sense that that 25 goes with 75, so maybe 75 goes with 25. A lot of people were looking horizontally, but that's not what we're looking for in this kind of a problem. What we wanted to do is look at these pairs of numbers vertically. And you take the numbers 10 and 90, and there are a lot of things you can do with 10 and 90. You could add them, you could subtract them, you could multiply them, you could divide them. So we just start trying each of these things. Now, I'm not going to try the first thing first. I'm going to just say, well, what if we try subtracting them? It's something natural we can do. If you subtract 90 minus 10, you get 80. Do you get the same thing when you subtract 75 minus 25? 90 minus 10 and 75 minus 25. That's 50. That's 80. That makes me sad. So unfortunately, so subtracting didn't give me anything good. So we try something else. You try multiplying them. 90 times 10, 900. 25 times 75. I don't know. Is it 900? It's definitely not 900, right? It's got to end in a 5. Okay, so multiplying didn't work. And you just play this game with the 4 basic operations. Add, subtract, multiply, divide. What do we get when we add the two numbers? I'm going to write down the sum here. 10 plus 90 is 100. 25 plus 75, 100. And then you verify that the pattern continues for all of them. You say, oh, that's it right there. They just add up to 100. 20. Okay, so then the equation. What did we do with the two numbers? Added them, and what did we get every time? 100. So two things, added up, and got 100. What were the... Yeah. Okay, so m plus t or t plus m, either way. Right? That's what we have. Now that's not exactly the answer to the blank there, but it's the natural way to think about things. We added them up and we got 100, but now we have this new vocabulary here that says find an equation for t. What does that mean about t? It's got to be by itself. So then we're going to start with the t equals. And then the m is going to be buried over here. And so basically you just have to move that m over to the other side. We'll talk about the algebra, but at this point, how do we move the m over? We subtract it. Is that okay? 100 minus m.
Oh, really?
So there's the equation for t in terms of m. Yeah. Okay, so that was the little demo part of this lesson. We move to the next page. You will find the classwork. You're going to get as far as you can in the classwork. We go until 10:45, so we have about 15 minutes. See how far you can get in the classwork.